Hey there, so I'm making this video to explain a little bit more details about my machine and her specs. And also I didn't mention it in the video that I posted before this, but English is not my first language, so I'm sorry if I mispronounce things incorrectly or I'm speaking incorrectly. Yeah, so be patient with me and let's go. So I made these new C-channel trays for the cable drag chain because the previous one got damaged. It's over there, but it got damaged when I switched my base table because I had to lift the gantry because I didn't want to disassemble all the gantry and it's really heavy. So I lifted up with straps and it's got damaged, so I made these new ones. So I'm just going to replace those. Some cap screws Allen from the inside, just a short piece of 40 by 80 extrusion, and another plate with some bolts to connect to the 160 by 80 extrusion. So I'm going to show you how it looked like when I finished. So I finished with one, a lot more stable than the other one, than the previous one, because this I didn't took as much as material from this one. I just wanted to be really lightweight, but I guess I did it a little bit. I've gone too far with this. Yeah. Also, it wasn't bent, so it just welded on some areas. Maybe was the issue as well. So it just broke off. As you can see here, I just zipped those in the meanwhile until I've gotten the new one ready. Maybe I will fix it, I don't know. Anyway, it's pretty. It's like art. So I connected the two trays. I have another tray that is going to be for the wide drag chain. I'm going to replace the one that I have there. And I want to show you in details how I designed this tray. So as you can see here, I have this little slot. So this slot is for zipping some other cables. And also, underneath I did also those slots, which are to connect the drag chain. And as you can see, there is holes all the way. So obviously you don't need to do holes all the way. I just like things to be really symmetrical. So yeah, this is what I did. And also those holes are to adjust if I needed to move this extrusion here or left or right. So I will have all the options. So I just want to make this really modular, sorry. So yeah, I'm going to finish connecting those. Also I extended this drag chain. Previously it finished here, and I didn't really like that the cables are kind of exposed here, so I extended those because I have a lot of drag chain spare from other projects. So yeah, I'm going to finish connecting those and I'm not closing the drag chain because it's really hassle to open all of those, you know, and I'm going to replace the motors. I'm going to replace some cables here already when my new controller arrives. So I'm just going to leave it open. On the back it closed though, just on the top. So I finished zip tidying all those cables that I needed. I'm just going to cut the ends. And right now I'm going to leave those exposed, as you can see. I really don't like this idea that they are exposed, but I just knowingly that I'm going to replace the motors and I will need to replace those cables. I just really don't like the hassle of putting the cover of like plastic tubes on them and then have to again cut all the zipping that I'm doing. So yeah, I'm just going to leave this like this right now, and when I will replace the motors with the new Innovance motors that are on the way, I'm going to do this properly. Also, I wanted to add that with the new Innovance models that are on the way, I'm going to like cancel this system, this anti-backlash system, because right now it's spring loaded, as you can see, so it will always stay right on the helical gear rack. But for higher acceleration and deceleration, it's really bad because the model will always have some sort of moving because it's a lot of force, and will be even more force with the new Innovance models that are 1.8 kilowatts. So yeah, I'm going to cancel this out, and I'm just going to put maybe adjust the accuracy of this helical gear rack according to the linear guide. So it will be so basically sorry that I'm mumbling. So I wouldn't have to do this spring-loaded system, basically. So yeah, just a little tweaks and updates, and yeah, those models actually are really fine. So they have really higher acceleration right now, but I can't really connect them to the new controller, which is in EtherCAT. So yeah, this is why I'm going to replace them. I'm going to leave some, I'm going to still use some of those motors because I do have like 5 interface ports for pulse and deer drivers, which are those. And the other models I'm going to use EtherCAT drivers. And I didn't want to have any issues with the symmetry or like with the synchronization of the of the models. So I figured that I will do the Y1, Y2, Y3 and X-axis EtherCAT. So I will have all the linear motion synchronized okay. And the Z-axis, I will also do EtherCAT because it wasn't really expensive, the motor, so I decided to do it as well. But the rotary axis, the B1 and B2, I'm going to still use those because honestly they have like a lot of power, because they really don't need to spin that fast. It's not like it's a lathe. So yeah, I'm going to still use those. And yeah. Also, I'm going to do like a version 2 of this chuck. This chuck is really good. I didn't have really any issues with it, but I find it just really hard to adjust the center of the lead screw, because the only thing that are preventing those lead screws to move left and right are those little Allen locks. So I didn't want it that all the load will be on these little Allen bolts. So I'm going to do some different system, and I will do a separate video for that as well. Also, I'm doing it more, I will do it a lot more robust, so it will be suitable for really heavy pipes, like with a really thick wall thickness. So yeah, I'm going to do a separate video for that as well. This is the third tray that I made for the Y-axis drag chain. Now, right now, as you can see, the drag chain goes directly to the cabinet, but there are some cables that don't need to go to the cabinet, like the optical cable, waddle, pipes, and also there is a lot of like spare cables length. So I don't really want to cut all of those because they are for the servo motors, which I'm going to replace almost all of them. So I don't really want to cut the cables because I don't know what I'm going to use them on. Maybe I'm going to sell them or build some other machine and sell the machine or something like that. I don't know. And also there is some basically those cables are going to the side. So I really didn't like this idea. So what I've done with the new tray, all the cables they don't need to go to the cabinet. I'm going to open the drag chain from below and take out all the cables that don't need to go to the cabinet from below. And this is why I made this design. So the cables will actually can go below the tray. So I'm going to show you how it looks like when it's connected. So it's assembled. Nice and sturdy. I connected the tray with this aluminum profile extrusion. It's probably a waste to use an extrusion for this, but I just had a lot of laying around from previous projects. So just did one and one here. And now all of the cables can just go down to the bottom. Just really a jungle of cables. But yeah, hopefully with the new motors I will have the time to do it more organized. I'm not sure how I'm going to be organizing it because it's just really long cables. So yeah, I will see what I will do. We'll keep you updated. First of all, I want to mention my machine specifications. So as I said before in the video before this, I'm using 2 kilowatts Zeusgripss, laser source, which can cut I think about 60 millimeters carbon steel, I think. And the travel of the cut area for cutting sheets, the size of it's like 155 centimeters and 310 centimeters so Y 310 and X 155. My Z-axis is a little bit different from a regular machine that can cut only sheets, because I needed my Z-axis to be longer, to have a longer travel, because it needs to go down to the chuck. So I overdid it a little bit with the travel length of the Z-axis. My Z-axis can go to the travel of it's 380 millimeters. So yeah, this is that. And the Y3 for the cube section, it can go about 640 or 630, something between those lines, centimeters. So it can accept a full long tube. So fiber lasers and sometimes plasma tables have these serrated slats to put the sheets on them, and therefore, so the fiber laser beam go over, and let's say I'm cutting here a line, so the line won't go over basically a teeth. Of course, it can still go over here, but the chances are much less to go over a teeth or another material when those are only the touching options that can actually connect to the touch the material that you are going to cut. So yeah, and all the materials that you're cutting, let's say the material that you don't need, like if you cut in a hole, the hole drops, so you need something that actually cuts, that actually catches all those things. And I did this rolling tray. This tray actually is very long. It's going all the way to the end. So that's catching all the stuff that I don't need, all the dropouts. It's most commonly to the trays in industrial fiber laser that you can buy from the manufacturer goes from the side, but here I don't have any side that I can actually roll over the tray, because here it's the tube cutting section, and the other side I have the control cabinet, drag chain, laser source, chiller, and stuff like that. So the only option that I had and that I thought that it's suitable, that the tray will be from the front. So that is that. My gantry design, as you can see, is very low. It's have about, I think, 200, something like 200, maybe less, millimeters from the cut area. And the point of this, so that the gantry will be very low. So it will be more suitable to higher acceleration, and then it will be more stable, basically. Because, as you can see, I really needed it to be stable because my z-axis is really high. So it really put out a leverage for the gantry. So this is why I put the gantry very low, and really you don't need a high gantry. You only cut in sheets. If you want to cut tubes on your table, I saw some people do that. I can still do that. I can still put a tube that is, as I said, probably 280 by 280, something like that. So it's a very big tube. So I can still put the tube here. I don't need it because I have my tube section, but I can still do it. But yeah. For the front chuck, it's a manual chuck that I designed. It can accept up to, I think, 140 square tube, 140 by 140 millimeters square tube. And the rear chuck is just a regular 4 jaws chuck. This is the pulley. This pulley is so big because in this design I have only on my controller, which is Centroid, it's a 4-axis controller. So I didn't have the option to do this axis separate from this axis. So they both are receiving the same signals. So I needed this pulley will be the same as this pulley. So this is why this pulley is so big. Regarding my control cabinet, I want to do a really big control cabinet. So I have a lot of extra space here because I thought that in the future I will actually put a dedicated fiber controller here. So it will have more boards or extensions. So this basically I don't use now. And this is the Acron board, this is the THC board, relay board, and all of other stuff. Here it's for all the limit and home switches. This is 24 power supply. This is 5-volt power supply. And this is all the drivers. I have 7 drivers. I have them labeled here: Z, B2, B1, Y3, Y2, Y1 and X, and here on the top I have my buttons. So basically those buttons, what it will do, what it's doing, they are only for a not dedicated fiber laser controller. So let me explain. This button is to enable the signal to the Y1 and Y2 models. So I will need to push it if I'm cutting sheets. If I'm not cutting sheets, I'm disabling them and I am enable the Y3. So this is Y3. Those are for the signal for the chucks. They are both pushed down because this is normally how they will be. I put the buttons for them because if for some reason the chucks are misaligned from each other, like say the rear chuck, it's like 5 degrees more than the front, so I'm just disabling the signal to one of those chucks and I'm adjusting so it will be more correct. This is for the Z-axis. So in the Acorn board, I'm not sure what is the reason, but this is what it is. So sometimes when I'm cutting tubes, like if let's say if I'm cutting all day tubes, sometimes the Z-axis is losing its position. So I'm just disabling it when I'm pushing it to the home switches, and I'm just disabling it. I'm zeroing out in the software and I'm enable it again. And this button is just general button. I didn't use it. I don't use it right now. Those are lights, so when the cabinet is on, the green light is on. And those two, I'm still not using them. Here I have a fan. There I have a fan as well. And that is it pretty much. I wanted to show you some of the process of an actual cutting. So right now, as you can see, just doing the contouring. One moment, it fell. To put this out as well so it won't hit the head. As you can see, the cut quality, the cut quality is really nice and shiny. This is 5mm carbon steel. Holes, round, nice, love it. Okay, let me resume the job. Take a look. Pierce. Alright, so what you saw is 3 stages of pierce. Because I can't really control the focus, at least in the program, I will need to pause the program, change the focus, and start again, which is not really realistic. So what I've done a custom code for my controller that I'm using, which is the Centroid board, which is a custom code for the pierce cycle. So for each pierce cycle, let's say this is for 5mm carbon steel, so I have a pierce cycle code for 5mm carbon steel. I have a dedicated pierce cycle for 8mm carbon steel, which they all have pretty much the same details, but let's say for 8mm carbon steel I will do a longer pierce cycle, or maybe I will add another stage, because the stages, because I'm not doing any focus change, the stages are for me doing a shorter time of pierce, and that way it will generate less slag, and the slag above, if there is a lot of slag above, it will mess up the cutting. So the cutting won't be as great, or the holes won't fail, stuff like this. So yeah, for 5mm and below, Centroid and all the custom code that I'm doing, which I'm using, are fine. They're cut well. Maybe slower, because as you can see, from point to point, it searches the material. So the cutting process is actually slower. because with a dedicated fiber laser controller you won't need to actually touch the material to know where the material is. It's all done through the amplifier and the capacitance sensor. Well, as you can see right now, it is using the capacitance sensor, and it's following the material really well. But to do a code specifically for the, it's called Auto Z cycle. So to do a dedicated code for this, I just don't have enough knowledge to do a code like this. A code like this is pretty simple, but to do a code for the searching the material through the amplifier, I still don't have. I need to do a custom PLC, and yeah, I just don't have the knowledge for it. I can learn it, but I really don't have much time for it. Although I would like to know how to do it. So yeah. This thing is the whole difference between plasma cutting and laser cutting. Everything is sharp, small holes are round. I don't have any beveling that I don't want to have. Yeah, I definitely prefer fiber laser over plasma. As you can see, everything, all the corners are very sharp, where they need to be, according to the drawing. Yeah, cutting is looking really nice. The perks of using laser. So with plasma it will be very difficult to get all those parts cutting correctly and accurate enough, sorry. So just puzzle. I love it, really. There is a tube that I'm going to put right here, and then I'm going to weld all of those. And basically it's going to be looking like this one over here. Those are some products that I make. Also guys, I just wanted to share my thoughts with you a little bit. So when I first built this machine, when I first ordered all the components for the machine, cost was really something that I need to consider, because I'm someone that has, like, I don't want to say more time than money, because I don't have time as well. But yeah, something like that. And a lot of my choices were depending on the cost. That's why I chose those Chinese motors. And this is why I didn't really replace my controller. And this is why I also gone with the manual focus head. So this is my opinion, that I tried really hard to save on the cost, and eventually it cost me more. So before those models, I had closed loop servo models, closed loop stepper models. After that, I changed those, and now I need to change them again because they're not suitable for the new controller. And if I have gotten the new controller, I didn't need to change those models again. And all of those changes are really time consuming, and I need to I need to take these plates off, this one, basically the plates that are holding the models for the Y1, Y2, Y3 and X. So I need to adjust them to suit the new models that have the shaft is bigger, so the spool gear that I have right now on the reducer is not suitable for them, so I need to order a new spool gear for them, helical ones. So all of those changes and all of those little things are also expensive and also really time consuming. And time is money, right? So yeah, at the end, I'm really paying more. It's still worth it to build one than to order one from China, which is a integrated machine for sheeting and tubes, because those factory-made machines are bigger, first of all. Obviously, they are better, right? They are more accurate. The whole frame is milled under a big milling machine, so obviously they will be more accurate. But the shipping is really costly, and you need somehow to get it into your shop, which those machines obviously are way heavier, which is it's a good thing because it will be more stable. But to transport here into your shop, it's really hassle, and it's not cheap. So this machine overall cost me to build something like $20K, and to purchase a combo machine for cubes and plate that you can put 6-meter tube on it. It's like something between $45 to $50K, and it's not include the shipping and the transportation to your shop. So personally, I think you're looking at something like 55 to 60. So obviously I saved money, and I would really like that my decisions were more, I put more thought on my decisions, because I didn't, it's easy to say that this, like now that I know that I got it wrong with those models, and I got it wrong with the controller and with the manual focusing head, because I cut a lot of thick plates. But yeah, this is something that I want to share with you for those who want to save money. And really think about it, if you're really going to save money, or you're going to spend money and a lot more effort and time consuming. So this is my journey, yeah. But if I had the knowledge that I have right now, it will save me a lot of time and a lot of money. So this is something that I want to give to you guys. So if you want to build a machine, really put your thoughts on it, and yeah, think if you're really going to save money or not. I love building machines, so this was a no-brainer for me, because I was really interested in knowing how this works. So I really wanted to build a machine. I really wanted to have this. I really want to have a success with building one and producing parts with it. But so yeah, this is the end. So those were my thoughts. I hope they are useful for you, so you won't need to pay a lot of additional costs and a lot of time of thinking about how to do things. If you will do things on the first go, how they are supposed to be, so you wouldn't have the issues that I've got. So there was a saying to listen to your dad and mom because they know better. So listen to the fiber laser equipment seller that you are going to buy fiber laser equipment from. Like if you're going to choose a Skyfire, so listen to them. They know what they're talking about. Listen to their suggestions and consult with them with the parts that you need. Obviously, you can save costs with some things, but the main components, my suggestions are to go with the stuff that are really suitable for your needs and for your machine specification that you are going to build. Yeah, that's it. If you want to buy laser equipment, go to Skyfire website and you can use my code, which is from Tamar. I will put a link to Skyfire website down below. Also, I will write my discount code, which is going to give you 5% discount. And also, they already have some great pricing, so it's going to give you even better price. So go check those out. And I said on my previous video that Skyfire has a lot of information about DIY fiber lasers, and they really put in like a list of all the information that you need to know about all the components that are going to be on fiber laser machine. So really suggest that you will go to Skyfire website and read all the information that they have there, because if not, you're going to regret it. So yeah, that's it.